find the inverse of a 3 by 3 matrix or of an n by n matrix, we actually have a really cool trick. So we're going to take the matrix that we want, matrix A. We want to find the inverse of that. So we're going to augment it with I, which is just our identity matrix. And then we're going to use a bunch of row operations, our good friends, loyal companions. Then we're going to end up with I on this side. So the identity is now going to be on the left side. And what's left over here? A inverse. So using our row operations, we can take any square matrix and we can reduce it down and try and get the identity on this side. So if you're doing this, going at home, I'm going to try and find the inverse of this 3 by 3 matrix. If you end up with something other than the identity here and you did all of your row operations fine, that's okay. That just means that A is singular, which means that A does not have an inverse. There's no inverse of A. But let's try and find the inverse of a matrix, and we do know that this matrix has an inverse. So let's suppose we have A, and we want to try and find the inverse of A. So what we can do, using our handy dandy tool we just learned, we can take A and augment it with our identity matrix. Okay, so now we're going to try and reduce this side to reduced row echelon form or the identity matrix. So the identity matrix is in reduced row echelon form, so we're just going to try and reduce this side to that. So first of all, we want to make sure that this pivot is the only non-zero term in our first column, so we just need to get rid of this 2 here. So we can do that by doing -2 times row 1 plus row 2 and making that our new row 2. So doing that, we're not doing anything to our first or our last row. Then we're going to take -2 times row 1 and add it to row 2. So -2 times 1 plus 2 is 0. -2 times -1 is 2 plus 0 is going to be 2. We'll make sure that this is in line here. And then -2 times 1 plus -1 is going to be at -3. And then -2 times 1 plus 0 is a -2. -2 times 0 plus 1 is 1. And then -2 times 0 plus 0 is 0. Okay, now we want to make sure that the pivot in our second row is equal to 1. But that would mean that we'd have to divide the whole second row by 2, and we don't really want to do that. So instead, let's take row 2 and swap it with row 3, just to make our lives a little bit easier. So just copy 1 down in there, just normally. And now we're going to take row 3 and copy it into row 2. And then copy row 2 into row 3. Okay. And now from here, we're going to want to make sure that this pivot variable is the only non-zero term in its column. So we need to get rid of this -1 and this 2. So we can do that by, we can take row 2 and add it to row 1 to get rid of that one, make that our new row 1. And then we can take -2 times row 2 and add that to row 1, or row 3, excuse me, row 3. So we're just going to bring that on down here. So now we will have, we're adding row 1 and row 2. So 1 plus 0 is 1, -1 plus 1 is 0. 1 plus 1 is 2. 1 plus 0 is 1. 0 plus 0 is 0. 1 plus 0 is 1. And now we're going to take -2 times row 2 and add it to row 3. So -2 times 0 plus 0 is going to be 0. -2 times 1 plus 2 is going to give us a 0. -2 times 1 plus -3 is going to give us a -5. And then our -2 times 0 plus -2 is going to give us a -0. Negative 2 times 0 plus 1 is just a 1, and then negative 2 times 1 plus 0 is going to be a negative 2. And now we're going to want to divide this whole last, we have to make sure we copy this one in. Can't forget about row 2. I'm sorry, row 2. And now we're going to want to make this into 1, so we're just going to multiply all of row 3 by negative 1/5. And then we're going to end up with this. Not doing anything to the top 2 rows, so just recopy those in here. Okay, and now all we're doing is changing this one, so we have 0, 0, 1, 2/5, negative 1/5 times negative 2. Negative 1/5 times 1 is negative 1/5. Negative 1/5 times negative 2 is going to be 2/5. Okay, now that we have this matrix, got very big there, I'm sorry. Now we're going to want to get zeros in these two places. So for our last step here, we're going to take negative row 3 and add it to row 2. To get rid of this pesky one right there, we're going to take negative 2 times row 3 plus row 1 for our new row 1. So for our final matrix here, we're going to do nothing to our third row, so let's just copy that on in here so we don't forget about it. Now what we're going to do is we are going to take negative row 3 and add it to row 2. So negative 0 plus 0 is just 0. Negative 0 plus 1 is 1. Negative 1 plus 1 is 0. Negative 2/5 plus 0 is negative 2/5. Negative 1/5 plus 0 is going negative 1/5, so it's going to be 1/5 up here. And then negative 2/5 plus 1 is going to be 3/5. And then we're going to take our negative 2 times row 3 times row 1. So negative 2 times 0 plus 1 is 1. Negative 2 times 0 plus 0 is 0. Negative 2 times 1 plus 1 is going to give us a 0. And then negative 2 times 2/5 plus 1 is going to give us 1/5. And then negative 2 times this, so we're going to have 2/5 plus 0 is going to be 2/5. See, all these fractions get crazy. And then negative 2/5, negative 2 times negative 2, or 2/5, is going to give us negative 4/5 plus 1, that's going to give us 1/5. So now we have found our A inverse. Hypothetically, this is going to be A inverse. So I would invite you to try this to make sure that we have found the right answer. Try A times A inverse. And if you get the identity matrix, then we have succeeded. This is the right answer, so I just want you to double check to make sure. And then we'll see you next time. Enjoy inverting some matrices.